All right, welcome back, fifth graders. We are going to do a little bit more challenging lesson today. Still dealing with area, so very similar to what we've been doing over probably the last week and a half. And we are definitely going to be using the ideas and the concepts that we've learned up to this point. That's the positives for us, is there's nothing new in terms of information. It's just that we are putting together what this highlighted figure is down here called complex figures. And the drawback with complex figures is we can't just plug in one set of numbers like we would for the area of a rectangle, for instance. 8 times 4 equals 32. Nothing like that. We can't do a formula for just a triangle, those kinds of things. But we have to do multiple formulas, and we really need to keep things straight. So I would say some of our biggest issues with today's lesson are going to simply be keeping things organized and keeping things consistent so we know where to find all of our information. So I am going to work on this top problem here and maybe one more down below, depending on how much time it takes us to get through this first one. But as you are looking at these, there are technically three shapes up here, but in all honesty, there are two different shapes. There's a right triangle and a rectangle, and the third shape is simply a combination of both of those rectangles, or both those shapes, excuse me. And so what we're looking at there is how we could best find the area of this third shape here, this one that we're looking at, that I guess you could say is a trapezoid. It does have one set of parallel sides, and it is a quadrilateral once we put them together. So those kinds of things are there, and it's very straightforward in what we're looking at. So the best way, or one of the best ways to find the area of a complex figure like this, guys, is to what we call decompose or break apart this figure into more manageable pieces. So in all honesty, we are going to start, I'm going to give them each a letter, C, B, and A, and we're going to start with shape C. Not to find the area of it, but just to talk about it and why it's so difficult for us to find the area of shape C. Okay? So as we look here, we can see that we have a base all the way across here of 10. All right? And we have a height to its tallest point, like we would for a triangle, straight up and down, of 4. So we've got those two numbers there, and you might think, all right, well, that's the way it is. But if we continue to use 10 as our base, that means our top of our shape would also need to come all the way out to the edge here. And if we used 4 for our entire height, that means we would need to include the top to come all the way over to this farthest edge. And we don't do that. We don't have that. Okay? So it makes it difficult to just, and we can't just use the 10 and the 4 unless we would rather find the 10 and the 4 for 40 and then subtract this piece that we're missing here, which is another way to do this, but I'm gonna not get off track here with our lesson for right now. That is another possible method. Okay? What the book is suggesting right now is that we find a natural breaking point. We find a spot at which we can easily break this up into two shapes. Okay? And here you can see that we have triangle A that we've got right there. And here you can see we have rectangle B. That's right here. So they have broken that apart for us, and then we simply need to find the area of each of those shapes and combine it back together. All right, so we got to remember the formulas. So for this top one, for triangle A, we've got area equals half of the base times the height, okay, or base times height divided by 2. Again, been doing that for about a week and a half now. So 4 times 4 is 16. Half of that is 8. So our area for triangle A is 8 square centimeters. All right, hopefully that makes sense and we know where we got those numbers from. For rectangle B, again, very straightforward, the easiest of the formulas for finding area, and that is base times height. In this case, we've got a base of 6 and a height of 4 for 24 square centimeters, which then means we need to go to the last question, which is combining those two things back together and now adding, not multiplying, but adding those numbers back together. 24 plus 8 gets us to 32 square centimeters. All right, so that is the stepwise approach that we would need to take. Now, you might think, well, that's not terribly hard, Mr. Mace, but as we look at these 4 or 5 problems down here below, guys, you can see that we do have a little bit more. Some of these shapes actually have 2 or 3 or 4 distinct different shapes that we might need to put a formula to, and so keeping one formula together, 2 formulas together isn't terrible. When you start to get to 3 or 4, it does make a difference. We also see that they are asking us for both the perimeter and the area. So now we got to, again, keep straight in our mind which numbers are important and which ones aren't. Okay? Because we are going to need that moving forward. So let's take a look at question 22 here, this little green, I guess I don't even know what part of a rectangle, I guess I'll just call it. It is a 1, 2, 3, 4, 5, 6-sided shape though. 6-sided figure, so we are talking about a hexagon. Okay, we are talking about a hexagon. So that means when we are coming up with the perimeter, we are going to need to add 6 numbers together. How many numbers do you see in this problem, 5th graders? 4 is what I hope you're thinking right now, and 4 I hope is what you're answering, because we've got 1, 2, 3, and 4. That means we are missing 2 sides. Okay, so to find the perimeter, yes, we are going to add 3, we are going to add 2, we are going to add 1, and we are going to add 5. Those are the 4 we know to this point. But we still don't know what this distance is, and we don't know what this overall height is. So we are missing those 2 sides to get to our hexagon of 6. So how can I figure those things out? Well, I'm going to find the height over here. I'm going to find this missing side over here. And how we would do that is we know, again, guys, that if we continue this shape all the way over, that these things need to total, this side here and this side here will equal what we have on the other side. So what is 2 plus 1? 3. So that means we have a height of 3. So there's one side that we found that's missing. And I know it's getting kind of congested here, and this is one of the issues we run into when we are trying to break apart a complex figure like this. You can also see that we have a base, an entire base of 5 centimeters, and so far we know that this section of that base is 3 centimeters. On the opposite side, well, that means we're going to need to do a little bit of subtraction where we needed to add before. 2 plus 1 got us to 3 for the height. Here we need to subtract. If we've got one side that is an entire 5 and the other side at this point is only 3, we should know that this small missing section right here is 2 centimeters. And again, I haven't written any labels down, but that is our 6 sides to find the perimeter. So we are now looking at 3 plus 2 is 5, plus 1 is 6, plus 5 is 11, plus 3 is 14, plus 2 is 16. So our perimeter for this hexagon is 16 centimeters. Okay, so hopefully you understand where we got that and where we are using those numbers from to find the perimeter. I think the most common mistake people make, guys, in finding the perimeter is they just add the numbers that they see and they don't really truly think about how many sides does a figure have, but that is a hugely important aspect of this. All right, so I'm cleaning up the area a little bit, and I am going to change colors just to give us a little bit more distinction between perimeter and area today. So we found the perimeter, and I will write in the numbers we are missing here. We decided that this length here that we were missing was a 2, and this length we were missing here was a 3. So now we need to determine where can I break apart this shape. And again, in all honesty, guys, it does not matter as long as we don't double up on any pieces. So for me, visually, I think that this is a natural breaking point, and I make 2 rectangles, A and B. And there is absolutely nothing wrong with doing it that way, especially once we find our sides that are missing and we know what numbers to use. So if I do it that way, that means the area for rectangle A is going to be a base of 2 and a height of 1 for an area of 2 square centimeters. And if we look at rectangle B, we are looking at a base of 3 and a height of 3 for 9 square centimeters. Now, as you look at that, fifth graders, you might say, well, Mr. Mace, you never used the 5. No, I didn't use the 5 because I didn't ever use that whole base for one of my rectangles. I broke that base apart by drawing my dotted line right here. Okay, so yes, that 5 does not come into play unless I chose to break it apart a different way. And I will show you one more method before this video ends and how to redistribute or break this apart in a slightly different way. But I then take those two areas, 2 square centimeters for rectangle A and 9 square centimeters for rectangle B, and I make an 11 square centimeter area for that entire piece. Now, what happens when I decide that that's not the way I see that shape being broken apart, and that I actually see it better breaking it apart this way? All right, well, again, in all honesty, guys, I actually have less work to do here because I don't technically need to find the missing sides. Okay, but if I make this A and this B, I'm going to go to this other side here. The area for rectangle A is a base of 3, which they already give us, and a height of 2, which they already give us for 6 square centimeters. And then as I look at rectangle B, a base of 5, which they already give us, and a height of 1. 5 times 1 is 5, and we still end up, when we add those two things together, with our answer of 11 square centimeters. Okay, so again, guys, it's all about your perception. It does not really matter which way you choose to break it apart. Just remember that you really don't want to break it up both ways, because now you've just added another step to the process and another thing to try to keep straight. All right, I'm going to try to squeeze one more in here before this video is up, just for some reinforcement and to show you that we can have a different shape here as well. Okay, that was just rectangles that we did, and this is kind of a repeat of the first question, but question 23 here. And oftentimes, guys, they will actually give us a natural breaking point. You can see the dotted line here to show us the height of that trapezoid. So as we look at this, to me, this is our natural breaking point as well. All right, that is a natural height that they found for us, and we know that this blue dotted line now that I've created is the equal to the 8 on the outside, which is also a straight up and down perpendicular line. Okay, it is a rectangle there. So if I'm finding perimeter, I've got all 4. This is a quadrilateral, 1, 2, 3, and 4 sides. So I'm going to add those all up, those 4 sides, to go 10 plus 5 plus 8 plus 11. To end up with a perimeter of 34 centimeters. All right, erase that just to clean it off a little bit so we can see our two shapes now that we're going to find the area of. Just to reiterate the same fact here. So I'm going to go back and I'm going to break that apart on our dotted line. So we have our two shapes. I'm going to say the rectangle is A and the triangle is B. Okay, now there is a little bit of work involved, a little bit more in this. If we are trying to find the area of rectangle A, well, we've got a legitimate base that goes all the way across the rectangle, and we've got a legitimate height of 8 that goes all the way from top to the bottom of that rectangle. So 5 times 8 equals 40 square centimeters. All right. Now, triangle B is where a little bit more work comes into play. We can't use the 10 as it is a leaning number. We cannot use this. That is only for the perimeter. It does have a height of 8. All right. And now the base, though, is where people tend to make the mistake. This is not an 11. We have already shaved from this point to this point off with the rectangle 5 centimeters. And sometimes it doesn't look like it, but that's another 6 centimeters right there. So our formula for this one is 8 for the height and 6 for the base to get us to 48. But then I've got to divide it by 2 to get to 24 square centimeters. All right, and our area then for that particular shape, that quadrilateral, that trapezoid, is 64 square centimeters. All right, please go to the exit ticket and make sure that you practice this skill. We will probably do these problems again tomorrow, very similar ones, and add one more new concept. Thank you very much, 5th graders.